So here's an example to get us started. Let's take the limit as x approaches 10, and let's let the expression in our numerator be the square root of x minus 6 minus 2. Notice with my pen, I'm spacing that out. You'd have to be careful to recognize where the radical ends in a problem that has normal typeface. And let's have the denominator of this expression be x minus 10. Notice again that if we tried to evaluate this with direct substitution, we have that problem value of 0 in the denominator. And if we investigate the numerator, plugging in 10 also gives us a value of 0. 0 over 0 tells us to do some algebra. So what we're going to do on problems like these is always rationalize the radical. This is going to seem a little counterintuitive in some cases, but it's going to do wonders for us. Remember that our whole issue is to fix the problem. And in this case, the problem is that denominator expression of x minus 10 that's producing a 0. So here's how we're going to do it in these sorts of problems. I'm going to take the expression that I have here, and we're going to multiply the numerator and the denominator by the same expression. Remember that anytime we do that, we're multiplying essentially by 1, where it's defined, and it'll change the appearance and let us do some simplification steps without changing the value. And what I'm going to choose to multiply by will be the conjugate expression. The square root minus 2 has as its conjugate the square root plus 2. All right, now let's remember our goal. Our goal is to fix this problem. The problem is coming from the factor of x minus 10. So I want to essentially leave this factor alone until something from the numerator emerges to help us divide it away. So what you won't see me doing in any of these problems, you will not see me multiplying these expressions out into an expanded format. I want to leave this in a factored form. I'm even going to put a set of parentheses right now. I want to leave this in a factored form until I find some way to cancel out this problem. So what we'll do in general is multiply the two conjugates, just like we did on our previous example. Multiplying the radical times itself is going to give us the expression x minus 6. Notice how it's no longer an irrational expression. I'm going to multiply the outer product and get 2 times the square root of x minus 6. The inner product, as we've seen in the previous example, gives me the opposite, negative 2 times the square root of x minus 6. And my final product is negative 4. So when we start to work this out, we're going to see emerge exactly what we need to divide away this problem. So notice how I'm keeping my word. I'm not going to expand those terms. So let's start seeing what's happening. We can see, of course, that plus 2 radical and minus 2 radical will vanish. And what we're left with x minus 6 minus 4. So as promised, everything's working out just the way we needed it to. We have a factor of x minus 10 in the numerator that we can use to divide a factor of x minus 10 in the denominator. And don't forget that when we divide those, essentially we're dividing and making a value of 1. And so we're going to use 1 as a placeholder to finish this problem. One of the common mistakes people make is their fraction bar disappears. All this canceling happens and they're left with this, but they forget that this still belongs in the denominator of the expression. So here we are. We have 1 as our placeholder. We have the square root of x minus 6 plus 2. And even though this might look weird, the truth is this function expression is continuous when x equals 10, and we can now evaluate this limit with direct substitution. Notice that's fresh. We have a 1 in the numerator. Plugging in 10 gives us the square root of 4. And ultimately, that simplifies down to 1/4. Now, this is a very systematic process. It pretty much works the same way in every example that you'll see. Your job is to get lots of practice at it. Once you start to recognize some patterns, maybe you can skip a step. It seems reasonable to me that if I know that the purpose of the conjugates is so that these radical terms vanish, then maybe I can find a shortcut after some practice to jump here that makes sense to me. And you are certainly encouraged to look for those shortcuts yourself. Let's do one more example like this. So let's take the limit as x approaches 3. And this time we'll have the square root of 3x plus 7 minus 4 all over x minus 3. Do a quick check that if we plug in 3, we do indeed get a 0 over 0 format. And let's use the same strategy as before of multiplying by the radical conjugate. So instead of radical 3x plus 7 minus 4, its radical conjugate is the square root of 3x plus 7 plus 4. There's our sign change. And we need to use the same expression in the denominator. As before, when I begin to simplify this, I am not going to do anything in the denominator except leave these in a factored form. Because when I'm done, there should be something to cancel away this problem. This is the 0 in the denominator. So I don't want to do anything to make that hard to find later. But in the numerator, I'm going to distribute those terms because that's going to give me the very factor I need to divide. So we have the square root times the square root. That leaves us with the expression 3x plus 7. You can see that my outer product of plus 4 times the radical, I'm just going to write that in abbreviated notation. Our next product is minus 4 times the radical. We can see those will eliminate. And our final product is negative 16. So let's see what happens as we clean this up. We have the limit as x approaches 3. In the numerator, the radical terms are gone. We have 3x plus 7 minus 16 plus 7 minus 16. That leaves us with 3x minus 9. And we still have our denominator expression. Can you see what's going to happen here? Can you see that embedded inside this numerator term is a factor of x minus 3? So essentially, we need to recognize its factorization so that we can have the factor to eliminate. And once we clean that up, sure enough, we're left with a factor of 3 in the numerator and a radical 3x plus 7 plus 4 in the denominator. We can now evaluate this with direct substitution. Plugging in 3, of course our numerator is 3. Here we have 9 plus 7, that's 16. The square root of 16 is 4. We've got plus 4, so 3/8 is the value of this limit.